4.1, combining functions graphically. And when we're doing this, graphically works fine, but it's also way easier to do it algebraically. And then you can kind of go backwards and do it graphically. But what you're doing is you're taking two functions, whatever it is, and you're actually asked to add, subtract, multiply, or divide them. The key thing is you have to have the two functions. You have to find the same x value. So once you have the same x value, all you do is take the y values and either add or subtract, multiply or divide. That's it. The key thing is they have to have the same x values. So probably the easiest way is to do this. Like, this is what all this says here is multiply, divide, add, and subtract. So flip to the next page and let's just look at the first example here. So what we have is we have two functions. We have f of x equals 2x plus 1, which is the linear line, right? Like, this is the linear right here, yeah? Oh, here, let me put a highlighter on here so you can see this. So that would be like the linear line. That would be like that one right there, yeah. Then you have y or g of x equals x squared. So that's the black one here. That's the black parabola right there. Standard one, 0, 0, 1, 1, right? So then what you're going to do is, in this case, we want to sketch the graphs of f, g, and h of x. And h of x is you're just going to take the two of them and add them together. So we've already sketched f of x and g of x, right? So now let's talk about h of x. So what we have to do is we have to find the same value. So for instance, x is 0 here and x is 0 here. Okay, so that works. Now, what are the y values? Well, if x is 0 here, y is 1. If x is 0 here, y is 0. So then all you do, our x value is still 0 for h of x, and all you do is take the other two values and add them together. So 0, 1. So that's 1 point. Okay. So you pick another one. So we have f of x and g of x. So let's pick x equal 1 and x equal 1. Here, when x is 1, y is 3. When here, y is 1. So the x value is still 1, right? Because you're just finding the same x value, and you just take your y values and add them together. So you get another point. So, I mean, graphically you do that with points, but I mean, this is kind of a little side thing here. Let's do it algebraically. So h of x is the two functions and you add them together. So 2x plus 1 plus x squared, add them together. So you get a polynomial and you factor it. And then if what you look here is because they're both x plus 1s, we have a perfect square, we end up with x plus 1 squared. So that is a parabola that's been shifted 1 to the left. So if you look, yep, there it is. That's the red one there. It shifted 1 to the left. So you could do that based on all the points, right? And then algebraically, you could check it. Like it's useful to do algebraically, and we have more of that coming up. Okay, flip page and look at example 2. So in this case, sketch the graph of h of x is f minus g of x. So given the graphs. So here you look at the graph, so you find, you see g of x is the green one, f of x is the red one. So f of x and g of x. So let's find 1. So we have, and you got to look at the scale here because this goes up by 0.5. So 1, and then that's 2 there. So f of x, that point right there is 1, 2. We have to find the same x values. So we look here at 1, -4. Okay. So then when we want to subtract them, because we have the same x values, right? So there's our 1 and our 1, and our bottom is going to be 1. You take the two values, so 2 minus -4 is positive 6. So 1, 6 is our new h of x, right? So you can see it here on the black. There's our 1, 6. Okay. Same thing here. Let's try -3. So -3 for g of x is -3, 0, and -3 looks like -2 for f of x. So the x values are the same, right? So that doesn't change. So we end up with what's that? -3. We take the two values, we end up with -2. So -3, -2. Yeah, there's our point there. Okay, let's do another one. Let's do this one over here. F of x of 0. So let's try when it's 0. So when 0, right, 1 is going to be there for g of x, and 1's going to be there. Oh, sorry. 1's going to be there for g of x, and this one here is going to be for f of x. So we look at our values here. 1 and -3, we subtract them, so we end up with 0, 4. And you can see that's the point, right? And then we have our 3 points, we can draw our line. So graphically, when you just get a graph like that, just find the same x values, look at the y's. The key is the x values have to be the same for this all to work. Okay, and then again down here, this is going to be later, but I'll just throw you an example in here. This is where we actually do the algebra, right? So f of x and g of x, well, we subtract the two, f of x minus g of x. So x plus 1 minus -x minus 3, right? You add all together, you end up with 2x plus 4. And you can see that that actually works, right? 4 would be here, then it would be up 2 over 1, up 2 over 1, right? But this part, this algebraic part is later on. It just makes it easier to show when we're graphing this. Okay, flip page. Let's look at example number 3. So this one, we have f of x is x squared plus x minus 6. So it's a parabola, right? With a y-intercept at -6, and then we can figure out the other part of it. And then we have g of x, which is 2x plus 6, which is just linear. So y-intercept of +6, then up 2 over 1. And then what we're going to do is we're going to combine them. So Here, the f of x one, right? You know how to do this. You can factor it, then you get your x-intercepts, right? -3 and +2. This is completing the square, so it puts it into vertex form, and then we can see the vertex is -0.5 and -6 1/4. And you should still be able to do this. This is what you need to do from grade 11. Now, a couple things when you're doing this. If you look at when you divide, g of x divided by f of x, right? We take out a 2 here. So we have x plus 3, and here we factor the bottom. We end up with a +3 and +3. Oh, this should look familiar, right? Down here and down here, they reduce down to 1, so there is a point of discontinuity. There is a hole in this graph. At what value? -3, and then you plug it into that. But there's also, if you look here, a vertical asymptote at 2. So there's our vertical asymptote, right, at 2. Right, it goes on this side and this side, but that circle right there is going to be our point of discontinuity. That's our hole in the graph. Right? So now what we're going to do is we're going to start taking all the things we learned in the past units and kind of putting them together, right? Graphing rationals. Well, we have to deal with asymptotes and points of discontinuity. But the main thing here is whatever graphs you have, whether you're adding, subtracting, multiplying, or dividing, you find the same x values and then look at what the y's are and then do whatever you need to the y. Either add, subtract, multiply, or divide. Okay, so that's 4.1.